Hi everyone. This semester we are working on a project to predict stock return and achieve SS returns, aka alpha, using neural network to analyze limit order book data. Our motivation is kind of simple. Three of us are graduate students studying financial mathematics, and it's a field where we combine computation, math, and statistics to solve financial problems. And naturally, we would like to see if anything we learn, in this case, neural net, can help us predict stock return and earn money. The data we are analyzing are data from limit order book. Historically, researchers use pre-specified stats model to analyze limit order book data and try to predict stock price. We will further explain what's limit order book in the next slide. So this is limit order book. There is a bid and there is ask. The depth represents the amount of bid and ask, aka how many stocks different investors want to buy or sell at a particular price. Investors submit the order of fixed price first to the exchange, and if the bid and ask price does not match, it will show as this chart look like. And you can see there's a gap in the middle. The data we obtain is 5 stock price from Helsinki Stock Exchange operated by Nasdaq Nordic. It's a pure electronic limit order market. And the system keeps a record of all events. Each data contains 10 days bid and ask price for each stock. For each stock, we arrange the data in a way the whole data set has 3 dimensions. The first dimension represents the timestamp, where we have around 420,000 times. The third dimension is the price and volume information that represent the best 5 bid price and the best 5 ask price, and their corresponding volumes. Finally, a second dimension represents the look back period. So for each timestamp, we have 100 look back price and volume information. Here is the structure of our final model. The inputs will contain price, volume, and price multiplied by volume information. Then those will be fed into 3 deep CNNs. And then it will be 3 neurons in the output layer. And we will concatenate the output data before feeding into the output layer. Finally, we apply the softmax function as the activation function to compute the probability of price going up, down, and neutral. The loss we use is categorical cross entropy, where we use AUC accuracy score as the evaluation matrix. So this is some of the methodology of our final model. We split the validation, training, and testing data set into 2:8:5 ratio. And we identify that there's no imbalance in the data set. For hyperparameter tuning, we try the learning rate of 0.01 and 0.001 using Adam optimizer. And we also try to mini batch size 256 and 1512. And we use categorical cross entropy as loss function. For our CNN model, we try filter of 16 and 64 of each. And we use decrease as activation function for CNN. And we let the model train for 50 episodes. We also try to lower and higher dimension data set using first 5 and first 10 limit orders to see if the performance will improve. In terms of results, here we can see the results of our final model. We train the model for 50 episodes and use Adam optimizer. On the top of the slide, you can see the position, the proportion, negative and neutral sample ratio in training. In terms of result for training, loss is 0.9397, AUC is 0.7343, and accuracy is 0.5398. In terms of result for validation, loss is 1.0836, AUC is 0.6448, and accuracy is 0.4654. For our overall test results, we have accuracy of 0.4502, provision 0.4572, recall 0.4511, and F1 score of 0.4499, which is considered actually decent, considering the industry. A successful trader generally have an accuracy score of barely above 50%. So in terms of the results, The contemporarily lower accuracy F1 score is because of the multi-dimension large test data sets. It can be further improved by using a more complex structure or architecture like CNN LSTM, which also includes memory feature. It has a potential to, therefore it has a potential to improve our classification matrix. Also, because of a lack of computation power, we can only use 10 days high frequency data. And could not further add to increase the LSTM layer. In terms of the application of this project, we implement a deep CNN model to forecast the signal and the sign of mid-price returns of selected US stocks. Therefore, people can build a trading algorithm based on the result of trading signal and combine a stock with predictive positive or negative indicates buying or selling. And a trader can consider use this implication alongside with other traditional fundamental analysis to build an algorithm to automatically execute the trading. Thank you so much for listening.